Hey everybody, I want to spend some time on Chapter 9 material here in CS160. It's a good chapter. Chapter 9 is actually a good chapter because it starts to connect the dots between the fundamental stuff we've covered in this class and the low level stuff like the binary and such that we did earlier, and it connects it with the Python programming that we've been doing as well. In fact, you don't see much code in the textbook until Chapter 9, right? And which is a common, not a complaint necessarily, but it's like almost like two separate courses are starting to converge together here. Chapter 9 is also cool in the fact that it shows you some other languages. And I wouldn't worry too much about that. I think if you skim through that, that's perfectly okay. I think that you look at the Python stuff, obviously, and if you look at one other, look at either the Java or the C++. Because if you enter the industry, you're likely programming in one of those three languages, Python, C++, or Java. If you end up skimming that part of the chapter, no problem. I think it's perfectly okay. There is a couple Python programs in Chapter 9. We're going to spend some time on the second of the two here in this video. And since it's an example code that's kind of at the level of complexity that we're getting to in this class, it's a good demo here of arrays and lists that I wanted to do this with this video. The rest of the chapter, this chapter is kind of in two pieces. The rest of the chapter talks about the software life cycle. And it tries to describe some of the stuff that's happening in the industry and, in development teams and software development in general. The challenge here is that the industry, the software engineering industry is changing faster than any other industry or technology. Massive changes in very short periods of time. And a newer book is already out of date. So for example, as I flip through the book, I'm thinking, okay, what is the book not covering that currently is common interview questions? And an example would be something about containers in virtual machines, which is not, it's a popular concept today used in cloud computing, but it's not covered in the book really. So it's important that you get the fundamentals. There's another interesting challenge. We can't do proper justice to the software lifecycle because our programs in this class are way too complex or way too simple here. And so it's important that you get a introduction to it. But to really understand it, you got to kind of live it, right? So again, Chapter 9, the objectives here as we go through it, helpful on the language comparisons, right? The software lifecycle, it's career essential, right? It's a good introduction, like I said. I'm going to share 5 points that kind of talk about development and the lifecycle, kind of as how I would summarize point number 2 here. And then we're going to talk about Python lists and arrays. So maybe I should have shown that first. So that's what we're going to cover here. The rest of this, let me show you my 5 key points here. I won't spend too much time on this here. The first one is you need to think about how you test from the minute you start. And some of you have probably picked this up from me already, because in the assignments, I'll talk about how I might test. Think about how I might test your program. And some of you have been probably surprised about, oh, I didn't think you would try that. Or, wow, it didn't occur to me that that might be a bug. And that's why I harped so early on the concept of, you got to check if you're going to divide by 0. That's just an example of a common bug in software today. So think about how you might test from the minute you start before you write a single line of code. And then equally true, and arguably more of a consequence here, is whatever you don't test will have bugs. Time and time again, this has been proven in industry. People make assumptions. Oh, I just copied that code over from a previous time, and then sure enough, there's bugs because the format's different, or the connections are different, or there's a use case that's different. And so what you don't test will have bugs, period. You can't prove me wrong on that one. Number 3 talks a little bit about agile software development. And there's a reason that I really like Agile software development. It's because it forces you to show progress every week. And if you're working on a project and you think it's going to take a year and your team has got a budget of $800,000 and so many people and so on, um, do you have to make progress every week? Yeah, technically not. You can have periods of time where the team is stuck or you're going into bug fix mode or something. But the bottom line is if you're in this kind of fog and you're just programming away and the next milestone is 6 weeks away, you're going to go through this period from now to 6 weeks where you have no idea if you're converging on that. And so an agile method helps you with that. And so it's important to you and it's important to your stakeholders. Point number 4 is it's kind of related, but I've seen too many times a lot of effort about kind of the details of, oh, when we get all this done, we're going to spend a week here, 3 days here, a week here, a month here, and so on. And it's like, that's 6 months out, guys. There's going to be a lot of changes in 6 months. So doing that level of detailed planning 6 months out is likely a waste of time. Things will change. You might want to think about what's the one thing that you have to pay attention to that if it changes, we have to do a replan. But I've seen teams get paralyzed because they do a period of planning. They get to the code, they start to code and realize they got to plan again. And some of you may have seen that as well. And then finally, and this is really important in software, if you and a teammate are working on something and you disagree on the method, pick something and move on, right? I want to write in a blue pen, you want to write in a red pen. Just pick one. There's no law that says the blue pen is better or the red pen is better. And this is a big problem in software because I almost said that almost always these choices are arbitrary. And that's probably not true. There's probably a lot of good reasons for choices. And so arbitrary is kind of a demeaning word there. But the bottom line is that, in many cases, the choice is close to arbitrary. And it's best to just pick one and move on. And if you learn and you make a mistake, you learn today versus learning in 6 months. And there's a terminology that I learned a few years ago around failing fast. The faster you fail, the quicker you learn. And there's just too many examples that I've seen where, 6 months later, you realize, oh, we should have done it that way. Or you argue about something for 3 months and then you move on and you realize, oh, it didn't matter if we used this programming language or this programming language, or this data structure or this data structure, or this tool chain or this tool chain, right? Or this code style or this code style, or this algorithm or this algorithm. And I can go on forever on this. So some things to think about. This is kind of my quick version of chapter 9, if you will, or the second half of chapter 9. Let's now switch gears and plug in some Python here. All right. I got some code I want to look at here. Here we go. We're going to talk about arrays and lists, and we're gonna finish this session by looking at the chapter 9 code that does this thing called the converging pointers data cleanup algorithm, and I'll explain what that is in a moment. But here, let's just talk about what a list is in Python. In Python, a list is just a group of elements that are in order. And many programming languages have this concept called an array. And let me just type that here, array, A-R-R-A-Y. And an array is often called an ordered list. It doesn't mean the items are in order. It just means the elements are in order. Okay, so let me give you an example of that, right? So if I create a list, my list, what is that? Okay, this is basically the initialization of creating an empty list. So if I print that, you see I got just square brackets with nothing in between. Now I can add something to the list by using this syntax. where I give my variable name, my list, and I go dot append, and I put what I want to append in there. So now if I print the list, I have a B, I have B in there, okay? The function len, or len, prints the length of my list, or doesn't print the length of my list. Len returns the length of the list. So you could see that I have a list item of 1. If I can also represent list items by using the numbered index into the array inside brackets. And so I know that the first element in my list is item 0, element 0. Now if I try this, I get an error because I only have the one element. And so basically my array index is out of range here, and that's what it says right here. Okay, let's append another item to the list. Okay, let's print the list. You can see I have the 2 elements here. Now if I try to print list element 1, oops, space in front of it, I get A. If I try to print list 2 or list 0, I get the B. And if I just try to print the list, I get B and then A. And so my point here is that these elements are not in order, right? B is after A, B is before A, whatever. And if I use numbers, it would be the same thing. My point here is that the elements are ordered, right? So each element in the array is right after the next one in memory. Let me show you one more thing, and then we'll move on to the example code. If I want to add one more item, let's look at the length again. This should give me 3, and it does. If I want to print out each element of the list, I can do something like this. And I get each element one at a time because I'm printing out the element with its index. I can also do this. So look, there's 2 different ways. I don't have this in my notes. I'll make sure I update this to my notes. This is an element, this is a method to look at the items in order using its element, basically the index into the array. Whereas this is just basically saying, give me each item and print them out. And so this top one is better in the fact that I have the position in the array as I'm going through in case I need it. Whereas the second one, I'm just getting the list items one at a time. They're going to do the same order and the same results. So it's only a matter of whether you need to manage the index for some reason, right? So for example, I might want to do something like this. List item I contains that gives me basically both pieces of information per element. All right, so let me just capture this in my notes. All right, good. All right, now let's take a look at the Chapter 9 code. Chapter 9, let me find that code here in the PowerPoint just to show it to you really quick, but we're gonna create my version of it, and you'll have access to it, of course. But this is the code I'm talking about, the converging pointer algorithm here. And it's figures 913, 912, and no, 913 and 914, I believe. Or 914 and 915, I think. I think this may be wrong. I thought it was 914. But here's how it's going to work, right? We're going to enter some numbers. And basically, we're going to strip out the zeros. Okay, and we're going to do that by going through the list in order, in order left to right. And if there's a zero, we're going to replace it with something from the end of the list. Okay, and I'm going to make a couple changes to it, as you no doubt might expect that I might do. But let's go through that. All right. Okay, so the first thing we're going to do is we're going to create an empty list. And in the example, the book asks to enter how many numbers on the list. I am not a fan of that method, right? I just want to enter my numbers. I don't know how many numbers are on my list. That's more work for me as the user. The computer can tell me how many numbers are on the list once I'm done, right? So I'm going to change that to use the Sentinel model. And this is something that you've seen me use before. It basically says, enter a number, if this, then quit. Right? Sometimes we have 0 be the quit number. Sometimes we have 999 be the quit number. In this case, I'll have the letter Q be the quit number. And I'm not going to do an error checking here. We can add that later. I'm just going to keep this simple here. But what I'm doing here is I'm setting n is equal to 0. That's going to be the size of my list. And then I'm going to enter a loop, and I'm going to get the input. And I'm not going to put an int around this input yet, because I want to check to see if it's a Q or Q. If it is, I'm going to break out of the loop. And if I don't break out of the loop, then I'll convert X into its integer value, and I'll append it to the list, and I'll increment my list value by 1. So let's see how that works. Okay, so you can see down here, enter a number, enter, so I can enter numbers. And eventually I'll enter a Q or a Q, and my program will quit. I can see since idle works that way, I can say, 6. 1, 2, 3, 4, 5, 6, right? So my length is 6. My last element in my list is element 5. And my first element in my list is element 0, right? Okay, so now that I have my list, I'm going to put this down here. You know, think about all the special cases that we would test here, right? The error checking I already mentioned here, right? So maybe I'll make a comment here. To do add error checking on input. Think about the special cases we would test, right? Because remember my comments from earlier, thinking about testing up front. If we have an empty list, we have to do something special, maybe. If the list is all zeros, we have to do something special, maybe. If the list starts or ends in some zeros, we might have to do something differently. And if there's a bunch of zeros in a row, we might have to do something differently. And so versus thinking about, oh, I'm just going to test it with 1, 2, 3 and move on, or I'm only going to test the program with the example that Jeff had in the assignment. It worked with that, so why wouldn't it work anywhere else? You got to think of all these other boundary cases. Okay, so here's some, and there may be more. But first we're going to check for the empty list. You can do that early and get that out of the way. Right? So if n is 0, we'll print an error message and we will exit out. Let's try that real quick. If the list, it'll just type Q off the bat. It says my program is running. Do you want to kill it? That's because you see it printed no list provided. And now I exit that. And we'll bring it back up here in a second. Okay, so you can even have this printed out on your desk and you could check these things off, or you can put an X next to it to indicate you checked it, and so on. But you can be sure that in programs like this, I will test for cases like this. All right, now using the method that we talked about earlier, we're going to print the list out. So let's run this. 1, 2, 3, 0, 1, 2, 3, quit. If I print the list out, I get it in this list structure, which may or may not be how you want to display the list. I will show you how to display the list differently later in the program using the other methods that I was showing you earlier. But we do know that we have 7 elements in this list, right? And so now we can get into the meat of the algorithm. Okay, and the way this is going to work is we're going to what the book does, right? It scans through the list, it finds a 0, and then when it swaps it with the element at the end of the list that has not yet been swapped. So in other words, think of it this way. You are keeping track of the pointer at the start of the list and at the end of the list. And you're going to work your way through the list. And when you hit a 0, you're going to grab this guy from the end of the list and you're going to stick it there. And then you'll put this, you can swap it, right? Or just put that there. But then you have a pointer to that end of the list and you just move it one out of the way, right? And so anything to the right of that point, well, you know those are 0s. So as you keep doing this, you keep popping over and eventually our pointers meet and we're done. Okay, does that make sense how that works? Maybe I can draw that real quick. Let me see if I can figure out how to draw that real quick. No, let's use a table. So we'll do some silly PowerPoint stuff here. All right. Oh, I should use different numbers. 5, 6, 7, 8, 0. All right. So the way this algorithm is going to work is, right, we're going to start with having a pointer here, and we're going to start with having a pointer here. And I'll change that to a different color so I can refer to them as different colors. We've got the green pointer and the black pointer. A pointer to an array is just the number that points to that index element, right? So this would be 0. And this guy would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be 9. Okay, so what we're going to do is we're going to move this, right? So we'll go first. This is not a 0, so we're good. So we move it to here. It's not a 0, so we're good. So we move it to here. Not a 0, we're good. We move it to here. Not a 0, we're good. We move it to here. Here we have a 0. So let me change this to be something else. We'll make that a 0. Now we see that this is a 0. Our pointer is here now, right? And it's at pointer is 4. So what we do is we take this value and we put it in here. And then we move this guy over. Because we basically know that this element, whether it was a 0 or not, is no longer relevant. Okay, and then we continue to do the same thing and we bring these pointers together until they meet, and then we're done. All right, so if that's confusing, then you can pause the video and try it again. Or once the program is done, you can run the program and you can kind of go through it and see, right? What we can do is we can add some statements in the code as we're working, which might help, right? But let's go ahead and do the next step here. All right. The book does this by finding a 0. And if we find a 0, place that element at the current end of the list. effectively eliminating that 0. All right, so let's think about how we might do that, right? We're going to create 3 variables. Oops. Left will be the current element of the list. That's our black pointer, if you will. Right will be the end of the list. And this other variable called legit will be where we know everything to the right of it is don't care. It's stuff that's either been copied in the list or it's zeros. And so we'll build a loop. And we'll start with basically saying as long as the value of left is less than right. So again, looking at that picture that we had, right? As the black pointer is moving to the right, the blue pointer is moving to the left. As long as there's space in between them, they're not the same, right? We're going to continue to do that. The first case, which I demonstrated on that picture, was, hey, the current element is not a 0. So if that's the case, right? So data element indexed by the variable left is not equal to 0, then just add 1 to the value of left. So you have one case where the element is not 0, and you have case 2 where the element is 0. Okay, so what do we have to do when the element is 0, right? The first thing is our legitimate list size drops by 1 because we have a 0, right? Then we do the copy that I showed you where we grab from the right, and we also have to make right equals, we also have to reduce the size of right. As I was coding the book's version, I thought, can I get away with not having legit and right and only having right? And I think the answer is maybe. It all depends on the implementation. But I'm going to stick with what the book did here. Okay? Because there is one other thing we have to do here. So when we get through this, left has gotten to right, and we have our list. There is one more thing we have to do. We have to check the final spot, because that could be a 0. And if that's the case, we just subtract 1 from the legit value. Okay. Again, this is maybe a 0's at the end of the list, right? And so that's an extra boundary case that you have to think about here. All right. So now our code is ready to go, I think. And I'm just going to change how we print the list at the end. I'm just going to go through as a while loop, right, to print through the list. There's a comment here about the final comment. I'll show you that in a moment. Actually, let me run the program, which I'll show you that, right? 1, 2, 0, 3, 4, 0, 9, 8, 0, 0, 10, 0, 12. Oops, quit. And there we go. So you can see here, when I printed the final list here, all the non-zeros are printed. But as you see, whenever there's a 0, we basically swapped it from items in the left, up from the right side of the list, kind of going from right to left. It's very efficient. But there's an interesting problem here. What if I wanted to keep my data in order? Right? What if I wanted the 3 to go there? Which seems like maybe that would be something I would rather do. Maybe. Kind of depends on the implementation. So that's an exercise for you to think about, right? And I'll put that in the code here so that you have it when you look at that, right? Selection sort, insertion sort, etc. may help you with that, right? And in fact, another method of doing this would be just to sort the whole dang list, but then the list would get sorted, which maybe I don't want to do, right? Because maybe if I run this, maybe, oops, 10, 9, 0, 7, right? Maybe I want the list to be in a different order, right? So now let's check a couple things. We already tested empty list. Of course, we've added a lot of code. We may want to test it again, but let's check this guy. All zeros. Final list is empty here. Maybe I want a different message here, right? Maybe I want to say, maybe I want to print out, hey, your list after pointer consolidation is empty. And that would be easy to do. Okay. Let's check for consecutive numbers. Okay, that seems to work okay. Let's check for zeros at the beginning. That seems good. Let's check for zeros at the end. That seems to be good. So those various combinations that I'm talking about, that's a level of testing that I like to see with your software. Okay. Now, if this code is confusing to you, that's no problem, right? You kind of go through it again and go through it again. What you can do is you can add some additional print statements, right? So you can do something like this. Sometimes it's good to put like debug in front of it, say, and sometimes it's even good to make some spaces here. Found non-zero at position left, value oops. Right? So this could help you, right? As something's not working right. And so you can do the same thing down here, right? And you can say found zero. Grabbing data from position right. So you can do this kind of stuff, and this will help you debug your code. And so all of these print statements are great. If you put debug print statements in your code, please take them out before you submit the code and test your program one more time. And or you can just even do this. You can make it into a comment, because I don't want all that extra stuff in your code unless your program's not working and you want to show me what you're doing. That's perfectly okay. But having debug stuff in your code is great. But remember, you're turning in production code to me, the debug stuff should be turned off. And in fact, you can even get more fancy and you could put all these debug statements inside an if statement, and you can have a flag, for example. I think that's everything I wanted to show you about arrays and lists. We're going to get into this with some of the next assignments, and this should arm you with what you need to go with. As usual, comments, questions on the discussion board, and thanks for watching.